Earlier this year, I made a video about the P102-100. Well, I'm making another one and adding another P102-100. Adding a second P102-100 gave me some results that at first seemed contradictory. A 27 billion parameter model got about 5 times faster. Two smaller models? Maybe 5%. And a 31 billion parameter model that ran fine on one card, but wouldn't load on two at all. There's a method to the madness, though. Some nuance. Things like whether the model fits, what spills over onto the CPU, how much room is left for context, and where the vision projector lands. Let's unpack this. I ran a battery of tests on a number of models. I ran the battery 3 times. For the larger models, I wanted to test splitting them up on two P102-100s and seeing how they performed speed-wise, especially since I got a lot of questions about that in the comments of my previous P102-100 video. For the smaller models, I wanted to see if I could split those models across 2 GPUs and run larger contexts. I didn't really know what to expect speed-wise. I mostly anticipated the larger models running multitudes faster on the dual GPU configuration, but I also had my doubts because of the P102-100's kneecapped PCIe 1.0x4 bus. For the smaller models, I thought there may be a good uptick in speed because now there were 2 cards running and doing work instead of just one, and the split layers of the model would be even less of a challenge, even for the aged Pascal architecture of the P102-100. Again, I thought this all relied on how much data needed to flow between the cards between their PCIe connections. If you were like me and thought there would be a good boost in the smaller model's performance, well, prepare to be disappointed. Well, kind of. For the small models, there was maybe a 4 to 6% increase in throughput. But for the variations of Qwen 3.6 27 billion I tested, things were a lot faster across 2 GPUs. Gemma 31 billion consistently ran out of memory because the projector file caused an out-of-memory error, but for the variations of Qwen 3.6 27 billion, there was a big speed up. An average of about 5 times faster than being run on a single GPU, where layers of the model are offloaded to the CPU and system memory. The last time I ran Qwen 3.x 27 billion, it ran at 1 token per second, and you all thought there was something wrong with the video and clicked off. But anyway, I was pleasantly surprised even with the CPU offloaded numbers. Gemma 4 31 billion's behavior at first glance seems a bit odd, but there's a straightforward explanation as to why it failed consistently. And that was because the testing harness I used was set to load the projector file, and while the layers were split between the GPUs, the introduction of the projector file and its default inclination to be set to GPU 0, the 1.2 gigabyte vision projector threw off the delicate balance of the already near capacity GPUs. I'm talking about VRAM in this case, and it consistently caused an out-of-memory error. Let's talk about the discrepancy in performance of Qwen 3.6 27 billion on one P102-100 versus 2 P102-100s. As you probably already know, when all the layers don't fit on a GPU, those layers run on the CPU instead. And CPU inference is brutally slow compared to GPU inference. In addition, when the GPU is working in conjunction with the GPU is waiting on the CPU to complete its tasks, which is why CPU usage spiked to an average of 38% utilization, while the GPU regularly found itself waiting, and utilized an average of only 14% utilization during the single GPU runs of Qwen 3.6 27 billion. The dual card generation resulted in an average of 34% utilization on P102-100 0 and 40% on P102-100 1. And again, because the workload all fit on parallelized optimized silicon, the dual GPU setup yielded about a 5 times increase in speed, even if 16 tokens isn't all that impressive compared to more modern GPU performance. Those modern GPUs are a lot more expensive in a lot more cases. Because a single P102-100 spends its time mostly waiting on the CPU, it draws 76 watts total, while a dual card setup draws 286 watts total, an average of 136 on P102-100 0 and 150 on P102-100 1. They're doing a lot more work because they're not waiting on the CPU. While the dual cards draw more electricity, this setup gets much more tokens per watt. And I'm not even factoring in how many watts my Haswell era Xeon draws when running at an average 38% utilization. For small models, when split across two cards, it costs you a bit more energy per token if you consider 47 to 49% more to be a bit. But the cards run 10 to 14 degrees cooler than a single card setup, and you get to configure much more context. So, the reason to get a second P102-100 or one of its sibling Pascal mining cards would be for significant speedups for bigger models, if they can fit your configuration, or for increased context capacity for smaller models. Really, these are maybe useful if you can find them for very cheap. If not, and I'm extrapolating here because I don't have any, but the specs back me up, maybe spend a little bit more for some P100s, which have full PCIe 3.0 16x slots and HBM, though you'll need to find a way to cool them.